Very good morning to all of you. Today I confine my talks on the basic concepts of correlation and regression analysis. Before going to the details, first of all we take a look towards what we covered today. First of all, what is the actual definition of correlation analysis? Then, the nature and form of data required. Thirdly, the types of correlation or different types of correlation. Then comes the methods of correlation, the different methods we use for correlation analysis. Then, the methods of correlation analysis separately, that is with the help of line graph method, with the help of scatter diagram method, the merits and limitations of scatter diagram method, correlation analysis by Carl Pearson's coefficient of correlation method, strength and direction of Carl Pearson's correlation method, methods of determination of Carl Pearson's coefficient of correlation, correlation analysis by Spearman's rank correlation coefficient method, methods of determination of Spearman's rank correlation coefficient, then the allied or associated issues with correlation analysis. Then we come in the point of regression analysis, different types of regression analysis, simple linear regression model with its explanation, regression line or line of best fit or least square line and the concept of residuals, drawing of regression line, and finally the types of residuals. So, first of all, in statistics, when we want to determine the relationship between two variables or different types of variables, there are two questions generally come in our mind. The first one is that there is any relationship exists or presence within that variables or not, and if the relationship exists, then what are the nature and form of that relationship? That is, what is the strength between the relationship of that variables, or what are the degree of magnitude or degree of association between those variables. So, these issues can be resolved using these particular two analyses, that is correlation analysis and regression analysis. In correlation analysis, the process of correlation answers that how strong the relationship is or how weak the relationship is. Whereas the problem of regression analysis depicts whether there is a relationship exists or not. If it exists, then what is the mathematical or algebraic form of that relationship? Now we come to the actual definition or detailed definition of correlation analysis. Correlation analysis basically is in our research inquiry is a statistical method or statistical procedure which is generally used to measure the nature and form as well as the strength of relationship between particular variables. Not only that, a high correlation points towards a strong relationship between the variables, whereas a moderate correlation plugs towards a moderate relationship between the variables, and a low correlation depicts a weak relationship between the variables. So, correlation analysis is generally used to compute the degree of association, that is how the variables varies with each other and how they produce a particular trend with each other. That is the main concern of the correlation analysis. In correlation analysis, there is a significant or important concept is correlation coefficient or coefficient of correlation. In correlation analysis, this coefficient of correlation analyzes basically the unit of change of one variable to another variable. That means, so in correlation analysis, the concept of coefficient of correlation articulates the change of one variable with the other variable. That if one increases, what is the changing nature of the other? Is it increases or is decreases, or what is the actual direction of change? Then we comes in the nature of data required for this correlation analysis. Correlation analysis is a simple technique, but there are some bindings related to data. First of all, the data must be numerically measured. That is, the quantitative data. The data must be quantitative in nature. Qualitative data is not suitable or applicable for general correlation analysis. And the second one is that we need continuous type of variable. As we know that there are two different types of variables, that is discrete variables and continuous variables. When we talk about continuous variable, then we must know that this kind of variables assume the whole values, that is even the decimal values, whereas the discrete kind of data includes only the integer values. So in our correlation analysis, we must need this type of continuous variable. For example, height and weight, and it includes all the whole values and including the decimal points. So for correlation analysis, the data must be numerically measured, quantitative in nature, and it must be continuous in form. And this precise type of analysis is mainly convenient during the establishment of the probable connection between the variables. But what are the nature between or nature of connection between the variables? Next we come the types of correlation. There are different types of correlations. These are the chief one, that is positive correlation, negative correlation, zero correlation or no correlation, linear correlation, and non-linear or curvilinear correlation. So first of all, when we talk about positive correlation, then this positive correlation indicates that when the nature of the relationship or the correlation between the two variables inclines towards a positive direction, then we call it positive correlation. That means both the variables changes its direction towards the same. The one increases, the another also increases. If the one decreases, the another also decreases. That means the direction of movement or the change of direction is same. For example, height and weight. Generally, we see that the taller people are more likely to be heavier. We can go through its diagram also. You can see this is the hypothetical diagram of a positive correlation. You can see easily that this is the y-axis and this is the x-axis. So, if we plot the correlation between y variable, that is dependent variable, and x variable, that is independent variable, then when one increases, the other also increases, and it shows a positive slope or positive direction. This type of correlation is called positive correlation. Then we come to the second one, that is negative correlation. When the nature of correlation between two variables inclined towards the opposite direction. That means if one increases, then the other decreases, opposite direction. Then we call it negative direction. From our daily geographical phenomena, you can take an easy example, that is the decrease of temperature with the increase in height. When we increase our height, then there is a decrease in temperature. That means there is a relationship, but the nature of the relationship is in opposite direction. That's why that is called negative correlation. We also correlate it with its diagram. You can easily see that again in the y-axis, with the help of the y-axis and x-axis, when we plot our correlations, then if one variable increases, then the other variable decreases. That means there is a slanting negative kind of slope. So that's why we called it negative correlation. Then we comes in zero correlation or no correlation. When the two variables are not correlated in any form or not at all correlated with each other, then we can't able to find any kind of positive or negative, particular or specific positive or negative trend within the nature of the relationship. That is called the zero correlation or no correlation. For example, apparently there is no correlation at all within the amount of water taken and the level of aptitude, apparently. So, if there is a zero correlation, then the diagram looks like that. That means the points scattered in a place and there is no definite positive or negative trend identified. That's why there is no correlation. Now we come to the linear and curvilinear correlation. When the nature of the relationship between the two variables, the nature of change is consistent, that is constant. Both are changed towards the same direction and in same magnitude. Then we call it linear regression or linear correlation. Its mathematical form is called linear regression. Whereas when the two variables are not linearly correlated with each other, then it is called the nonlinear or curvilinear correlation. We can easily understand this with the help of two simple examples. First of all, the linear correlation. Suppose we increase the number of laborers in a cotton factory just double, and the output of the cotton factory, when we analyze, we see that the output also doubles. This kind of relationship is linear in nature. That is linear correlation. Whereas when, suppose on the other hand, if there is a 25% increase in our income. So as you know, income and expenditure is related with each other, but that is not constant. With the increase of 25% in income, the expenditure may increase 5%, or it may increase 15%, or it may increase 10%. That means the rate of change or the ratio of change is not constant. That's why it is known as curvilinear or non-linear, which is not linear. Non-linear correlation. This is a kind of linear correlation. That means when the two variables changes or the ratio of change is persistent. That's why there is a positive slope also. But in the case of non-linear correlation, you can see that as the rate of change of the relationship between the variables is not constant or at par with each other, that's why it shows a curve-like trend line. So that is a hypothetical diagram of non-linear correlation. Now, we can go through the methods of correlation. That is, what are the different methods through which we can able to see the correlation and its nature. That is, whether it is positive or negative, or there is either any type of correlation or not, or it is linear or curvilinear. So, in terms of method of correlation, we can express it through line graph method, with the help of scatter diagram method, with the help of Pearson's product moment correlation method, or with the help of Spearman's rank correlation coefficient method. Now, here is the correlation analysis by line graph method. Here we can see that in y-axis we show the number of rainy days and average annual rainfall in millimeter. Whether in x-axis we show the 12 months. And you can see that the orange color curve and the red color curve both shows the average annual rainfall in millimeter and the rainy days or number of rainy days respectively. So, if we want to show the correlation between two variables in a single graph at a glance, then we may perform or we may draw this kind of line graph. You may use different kind of statistical softwares for this kind of drawings and measurements, within which SPSS, Strata, R statistics, all are very much user friendly and good statistical softwares. I will show you this kind of drawing of this kind of graph or line graph method through our Microsoft Excel in a very simplified form. Now, in Excel, in Microsoft Excel, this is a hypothetical data for your line graph. Rainy days in column A or number of rainy days in column A and average annual rainfall in millimeter in column B. So, if we want to draw a line graph to show the nature of relationship or correlation between the two variables, that is rainy days and average annual rainfall, first of all you go in the insert option, then you go for charts, different kinds of charts here. So as we want to show the correlation with the help of line graph method, then we go through line, then you see that different kinds of line graphs there. We can select any kind of line graphs. So before selecting that, first of all, we select our data set, then we go through insert, then we go through line, then we select our line option, and then this kind of line graph will present. Then here is your rainy days and here is your average annual rainfall. And if you want to put your axis titles here, then you may go through the design or through the layout with all the arrangements, that is the heading, the index, the axis title, etc. So, this is a very simple line graph you may perform. Now, correlation analysis may also perform with the help of scatter diagram. Scatter diagram is basically a very much convenient method for our correlation analysis. So when we talk about scatter diagram method, first of all, we take a look towards the merits and limitations of this scatter diagram method. The main merits of the scatter diagram method is that it is very much simple and very easy to understand the correlation or the nature of correlation between the studying variables. Second one is that just with an overview on any type of scatter plot, you can ensure the values of the variables, the exact values of the variables, and also the existence of any kind of relationship exists between those variables or not. That is, it is a very quick method through which you can analyze or you have an idea whether there is any kind of relationship or not. The third one is that scatter diagram also specifies whether the relationship is positive or negative. As we previously discussed that there is different types of relationship: positive, negative, zero or no correlation, linear or curvilinear. Any kind of relationship you can easily identify through the help of this scattered diagram method. But the main limitation of this very much liquid and convenient method is that scatter plot doesn't show the quantitative extent of the relationship between the variables. That is, it just states you or tell you that the relationship exists or not. But what is the amount of that relationship, or what is the actual extent or degree of magnitude of that correlation, the scatter diagram or scatter plot doesn't show that. And second one is that correlation does not mean and not show any kind of causality. It is not able to identify any kind of cause-effect relationship, that why that kind of relationship occurs, why it is positive, why it is positive, it is negative, why it is negative. And if there is no correlation, why there is zero correlation. Scatter plot is not able to identify that. And the third one is that it cannot be used to show regarding more than the two variables. That is, it is a bivariate plot which is only associated with two variables which must be quantitative in nature. This is a scatter diagram or scatter plot based on the previous hypothetical data, as you show that average annual rainfall in millimeter and number of rainy days. So when we compare that two variables, that if there is any relationship exist there or not, so you easily identify that there is a positive trend. That means as the average annual rainfall increases, the number of rainy days also increases. That means there is a positive correlation exists between the two variables. Thus, as we discussed that this scatter plot in terms of limitations, as we discussed that this scatter plot must be quantitative in nature, easily we can identify that average annual rainfall data is quantitative in nature, and also the number of rainy days related data is also quantitative in nature. And secondly, this is a bivariate data. That means there is only two variables. So, if we want to prepare this kind of scattered diagram through our Microsoft Excel, then first of all, you select your data set, then go through Insert, then you can see that there is scatter plot. Different types of scatter plots there. So we select this. So this is the scatter plot. And if you want to add a trend line within, that is, as we see that there is a positive trend. if we want to be more precise, we add a trend line. That you select these points, right click, add trend line. Then, as this is our linear relationship, that's why click on the linear checkbox, then close. This is your trend line, which show the positive trend between the, or to identify the relationship between these two variables. And again, if you want to add your heading, your index, your axis title, you may go through the design or you may go through the layout or different chart tools. Now we come to the third method, which is very much important, that is correlation analysis by Karl Pearson's coefficient of correlation method. Basically, this method is derived by Karl Pearson in 1920 with the help of arithmetic mean and standard deviation. That means, as we calculate the coefficient of correlation with the help of Pearson's method, then it is generally either you calculate it manually or through the software. It is based on mainly two issues, that is arithmetic mean and the second one is the standard deviation. So there are certain assumptions regarding the Karl Pearson's method. First of all, the level of measurement, that means you have to measure the each variable quantitative in nature and each variable precisely. Second one is that there must be related pairs. That means, as we talk that garbaging in and garbaging out, that is applicable here. That means if you want to show the correlation between the two variables in Pearson's method, then you have to select only those variables which are related to each other. Which are not related at all with each other is not suitable for this kind of method. Then comes the absence of outliers. Outliers are basically a specific term we use in regression diagnostics, basically associated with correlation also. Outliers are basically the extreme values. That is, in a data set, if there are some values which are extremely small or extremely large, it influences the nature or distribution of the whole data set. And when we perform any kind of statistical analysis with that data set, these outliers may influence the nature of the analysis. So, if you want to perform a correlation coefficient method to analyze any kind of correlation between variables through Karl Pearson's method, then an important assumption is that there must be no outliers. Then comes linearity. That means the two variables must associated with each other linearly. That means there is a, so linearity is an important concept regarding assumption of Karl Pearson's coefficient of correlation method. Because if the variables are not linearly correlated with each other, the Karl Pearson's coefficient of correlation method will not be fruitful or actual for the analysis. Then there are some merits and limitations regarding this particular method of correlation analysis also. That is, this technique indicates the presence of correlation between any two variables and regulates the exact degree of correlation between those variables. That means, during the time of discussion of scatter diagram, which one was the limitation? That means, through scatter diagram, we just identify, or we just able to identify the relationship exists or not. But we are not able to identify that what is the exact degree of that association. The main merit of Pearson's correlation coefficient is that it determines that degree of association, or that amount of association through which the two variables are correlated. But the limitation is that the calculation of Pearson's correlation is comparatively complicated. If you want to go through manually, there are a number of lengthy calculations you have to perform. So, it is comparatively hard to calculate, and apart from this, the value of Pearson's correlation coefficient is very much affected by the values of extreme values, that means the outliers. It has a tendency to be more influenced by the presence of outliers. This is a particular limitation of Karl Pearson's method. Then, if we go through that, what are the methods of determination of Karl Pearson's method? First of all, we may categorize it to broad classes. That is, coefficient of correlation for grouped data and coefficient of correlation of ungrouped data. When we talked about ungrouped data, there are direct method. The first method is direct method. In direct method, the coefficient of correlation, that is Pearson's coefficient of correlation, is denoted by small r. That is, Rxy, coefficient of correlation regarding xy, equals to summation of xi minus x bar. Xi means the individual values of independent variable, and x bar means the mean of that variable, into yi minus y bar, that is yi, the individual values of the dependent variable, and y bar, that is the mean of that variable, divided by under root xi minus x bar into within root yi minus y bar. This is a popular and general method for the calculation of Pearson's coefficient of correlation. This is a lengthy process, so that's why a shortcut method is derived. When we consider any data set, sometimes we can see that there are small values or small number of observations, and there are large values with large number of observations. So, for that different criteria, for small values, the shortcut method will be Rxy equals to summation xi yi minus xi into summation yi divided by n. Here n denotes the number of observations. That is 1 to 20 or 1 to 2000, like that. Divided by under 1 root xi square into summation of xi whole square divided by n, that is number of observation, into summation of yi square into yi whole square divided by n. This is the shortcut method for small values and where the number of observations are small. Now, the second one is for large values. When we have large number of observations and the values, that is the size, is also large. There Rxy equals to dxi. Here d is the distance. dxi into dxi into summation of dxi into dyi divided by n, all divided by within root dxi square minus summation of dxi's whole square divided by n into dy square minus dy's whole square divided by n, where dxi equals to x minus xa and dyi equals to y minus ya, and a stands for the assumed mean. Then we go for ungrouped data. So when we talked about ungrouped data, there is a very short step deviation method. Step deviation method is very much short, and here the Rxy equals to summation of dxi into dyi minus summation dxi into summation dyi divided by number of observations, that is n, divided by under root dxi square minus dxi whole square divided by n into within the root dxy square minus dyi's whole square divided by n. That means the parameters are generally more or less same, but the process of calculation are little bit lengthy or little bit short, as it varies with the nature of the data. Now we come to the determination of correlation coefficient from bivariate grouped data. Previously we discussed the number of ungrouped data, a number of methods for ungrouped data. Now we consider then when you have grouped data, then you may perform this through Rxy equals to f, that is frequency, fd xi dy minus summation of f dxi into summation of f dyi divided by under root summation of f dxi square minus f dxi square into within the root f dyi square minus f dyi square. This is applicable for your grouped data. Now we come to the correlation analysis by Spearman's rank correlation coefficient method, and from the heading or from the name we easily understand that this kind of coefficient of correlation method is very much applicable for ordinal or ranked data. This particular method is developed by Spearman in 1904. First of all, like Pearson, this particular kind of measurement has also some assumptions. Let's see. First one is data must be ordinal in nature. That means you have a data set which is ordered or which is organized in an orderly manner. Ordered data or ordinal data and ranked data. That means there are some ranks. Instead of the raw data, if you have any kind of ranked data, you can easily correlate that ranked variables through the use of this Spearman's correlation coefficient method. Second one is the effect size. The second assumption is that the query standard may be used to evaluate the correlation coefficient to determine the particular measurement. Like the another methods, these particular methods also some merits and limitations. So first merit or benefit of this method is that this Spearman's rank correlation coefficient is that the values of the independent and dependent variable, that means your x variable and y variable, can be continuous or ordinal or ranked. That means there is a wide variety within the nature of the data set. An estimated normal distribution for independent and dependent variables not required. That means in other analysis you must have a kind of data set where the probability distribution is normal. But here the Spearman's rank correlation coefficient, that normal distribution is not always required. Moreover, it is very much simple, easy to calculate and easy to understand. And it can be figured with any kind of variables like dependent or independent. What you have. But the only limitation is that Spearman's this kind of correlation coefficient is not very much precise like the Pearson's or general methods. When we have a large data set or when there are a number of outliers like that, then it may influence the value of the coefficient of correlation. Then the next issue is that how we can determine the Spearman's rank correlation coefficient. We can determine it through two different methods. The first one is untied rank method and the second one is tied rank method, that is pair. In the case of untied rank method, it is defined as rho is a Greek letter, rho y upon x equals to 1 minus 6 summation of di square divided by n into n square minus 1, where the d is the distance between two ranks and n equals to the number of data or your number of observations. Second one is the tied rank method. It is slightly different from the untied rank method, where rho yx equals to 1 minus 6 into summation di square plus summation t3 minus t by 12 divided by n into n square minus 1, where di, as you know, distance between the two ranks, t equals to number of tied rank, and number 3, that is n equals to number of data or the observation of data. Now we come to the regression analysis with a special emphasis on simple linear regression model, which is very much applicable in different kinds of data set and in our geographical studies and in different types of research works. This particular regression analysis, there are different types of regression analysis, but within that the simple linear regression model has a wide use. So first of all, we know that what is actually regression mean. Regression analysis is a very much convenient and consistent method of recognizing which variables are important and which one are not so much important. So, the process of execution of a regression permits to determine the factors, that is, which are the most influential factor and which are not so important that we can remove it or we can overlook it. Formulating a regression analysis generally helps to predict or help to determine the belongings of the independent and dependent variable. That means in correlation analysis, as you study the nature of relationship, regression depicts the form, the mathematical form of that relationship, the quantitative extent of that relationship. Now, we go through types of regression analysis. Regression analysis may be of various types. As you previously know that linear and non-linear correlation, like that linear and non-linear or curvilinear or logistic regression, where in linear regression there is a linear relationship, or in curvilinear or non-linear regression there is a curved relationship, where in linear relationship the rate of change is persistent or constant. In curvilinear it varies with each other. Apart from that, there is a simple or bivariate regression, multiple regression and multivariate regression. In today's statistical analysis, this multiple and multivariate regression has a wide use, because in our daily life or in our practical experience, there we may generally deal multiple variables instead of univariate or bivariate data. So, what is the difference between that simple or bivariate, multiple and multivariate? When you consider the simple or bivariate regression, you have only one predictor or one predictor variable. That is y equals to a plus bx. That is, y is your dependent variable and x is your independent variable. When you write this mathematical form to express the simple or bivariate relationship, you have only one predictor variable, that is x, only x, one. The second one is multiple regression, where the relationship is y equals to a plus b1 x1 plus b2 x2 and so on bn xn. That means your dependent variable is 1, but your predictor variable is multiple, x1, x2, x3, xn. And the third one is multivariate regression. In the case of multivariate regression, you have a number of response variables. That means your responses are multiple, that is y1 to yn. So this is the form of different types of regression. Now we focus on, or we give a special emphasis on simple linear regression model with explanation. This kind of regression model has a number of assumptions. That is linearity. You must have a linear structure. That means your variables are linearly correlated with each other. That's why it is called linear regression. Second one is independence of error. Your error terms, later we come, your error terms must be independent with each other. Third one is homoscedasticity. The variation around the line of regression be constant for all values of your all independent variables. Then normality, the dependent variable, that means the y variable must be normally distributed. The probability distribution of the error terms must have constant variance. Variance must be constant. And the underlying relationship structure of the dependent and independent variable must be linear in nature. Linearity is essential. These are the assumptions. Now, the nature of variables. What type of variables you need for simple linear regression model? That is, the independent variable or your X variable, it is called the explanatory variable or predictor variable as in the previous one. And the dependent variable, that is your Y variable, it depends on the independent, that is your X variable. It is called the response variable or dependent variable. That is the two kind of variable, one dependent and one independent. One is predictor and one is response variable. That is the two kind of variables you need for your study. Then comes the very significant part, that is determination of regression line. In the case of a general form of regression line, you can see y equals to alpha plus beta x plus epsilon. That is, y is your dependent variable, as we know. X is your independent variable. Alpha is your intercept. When we determine the relationship between two variables, there are two parts. That is explained part, which we can calculate mathematically, and the another one is unexplained part. This alpha is the fixed causes, which are not determined by us or mathematically determined by us. So, this alpha is the intercept or fixed cause. And beta is the slope of the independent variable. That means the beta amount of independent variable increases or decreases or changes the amount of change of y variable, that is your dependent variable. That means as the y variable, that is your dependent variable, depends upon your x variable, the rate of change of that x variable which influence the dependent variable, that is your y variable, that amount of change is denoted by beta. And the third one is epsilon, that is random error term. Due to sampling process and sampling procedures or methods, there are sometimes a number of error occurs, which is also the unexplained part of the regression and also sometimes not determined by us. That is called the random error term. So this is the general mathematical form of a regression line. And there is another concept of residual. Residual is basically a particular process or particular issue that differentiate the expected value and the observed value. That means what is the difference between the observed situation and the ideal or expected situation. That is your residual. These are the two methods for drawing of your regression line. That is least square method and the another one is correlation coefficient method. Basically, with the help of these equations, we can easily solve that what will be our line of best fit. This is our regression line. So, and these are our observed points. So, this is our residual. That means if we consider this particular value, then this is our measured value. We observed it or measured it. And in ideal situation, it should be plotted in like that position. So this is the ideal position and this is the measured value. That means the predicted value and the measured value. So the difference between this measured value and predicted value, this gap, this red colored gap is known as your residual. There are different types of residuals. That is absolute residual, yi minus yc. Here yc is your predicted dependent variable. Yi is your dependent variable. The second one is relative residual, 1 minus yc by yi. And the third one is standardized residual. That is yi minus yc by standard error of estimate of EYX. That is SEYX. Now, it can be concluded that in our present day study or any kind of research work or any kind of example or any kind of situations or incidences which has a cause and effect relationship where the correlation varies and the correlation influences the outcome of the incidence, then we must apply this kind of correlation and regression analysis to define the exact nature and form of that relationship and the mathematical expression of that relationship so that we can easily conclude or the total depiction or total description of the cause and effect relationship will be more precise and will be more fruitful. So these are some of the bibliography and references. That's all for today. Thank you to all of you and best wishes for your future preparation.